Hello, everybody. Factoring trinomials with leading coefficient of 1. Okay, suppose I have um, x to the second minus 7x plus 10. It is a trinomial. I have three parts, and the leading coefficient is 1. So I'm going to be looking for two numbers that add up to the middle term, in this case, -7, and multiply to the last term, 10. So how about -2 and -5? They add up to -7 and they multiply to +10. So my factoring is going to be x minus 2 and x minus 5. Okay, and I can test myself. I can tell you that, notice that x times x is x to the second, x times -5 is minus 5x, and then -2 times x is minus 2x, and -2 times 5 is positive 10. And notice that these middle terms add up to -7x. So yes, it worked. Let's do another one. How about uh, x squared minus 2x minus 24? I'm going to be looking for two numbers that add up to -2 and multiply to -24. How about, uh, let's see, how about -6 and +4? Yes, they add up to -2 and multiply to -24. So my factoring is going to be x plus 4, x minus 6. And it doesn't matter which one of these you put first. It's the same as saying x minus 6, x plus 4. Okay, let's do another one. How about x squared plus 8x plus 15? Looking for two numbers that add up to 8 and multiply to 15. Well, how about 3 and 5? How about 3 and 5? So now my factoring is going to be x plus 3, x plus 5. So at this point, you're going to look at this and you're going to wonder, is everything is, factorable? In other words, are there trinomials that we cannot factor? And the answer is that yes, there are some that we cannot factor, and we call them prime. And let me give you an example of that. Suppose if I have x to the second minus x plus 1, okay? Are there two numbers that add up to -1 and multiply to +1? Uh, I don't know such two numbers, +1 and -1 don't add up to -1. -1 and -1 don't add up to -1, and +1 and +1 certainly doesn't add up to -1. So this one is prime. This one is prime. Well, there are sometimes that the leading coefficient is not 1, but I can easily factor it out. Suppose I have, let me change color, 2x to the second plus 10x plus 12. Well, true, the leading coefficient is not 1, in this case is 2, but notice that I can factor that out because there's a factor of 2 in all three of these. So I can factor my GCF, greatest common factor, and claim that this is the same as x to the second, 2 times x to the second, plus 5x plus 6. And now the leading coefficient in here, inside of this parenthesis, is a 1. So I can go ahead and factor that. Here is my 2 from here. I'm looking for two numbers that add up to 5 and multiply to 6. Sure. X plus 2, x plus 3. And let's do one last one. Suppose I have 4x to the second minus 12x minus 40. And the leading coefficient is not 1, but there's a factor of 4 in all three of them, here and here and here. So I'm going to factor out my GCF, greatest common factor, and claim that this is the same as 4 times x to the second minus 3x minus 10. And look inside of parentheses. My leading coefficient inside of parentheses is now 1. So I'm looking for two numbers that add up to -3 and multiply to -10. So x, how about -5 and +2? Okay. Uh, and let's just test ourselves. Here, x times x is, here's my 4, is going to be x to the second. Then I have plus 2x. Then I have minus 5x. Then I have minus 10. So that equals 4 times x forward minus 3x minus 10. And if I multiply the 4, I get 4x to the second minus 12x minus 40. I will do another video with a leading coefficient other than 1, something that we cannot factor it out. For now, if you have any question, email me. Thank you.